Hello, this is Dr. Grafton, and in this video we're going to be going over assignment 4.3, chapter 10, regression analysis, estimating relationships. We've talked a little bit before about linear regression because we've had an assignment where we did scatter charts, and scatter charts is a visual way of maybe looking at a line slope formula. In this particular assignment now we're going to look a little more further at linear regression. We're going to look at the equation. We're going to look at some other parts of that, and also how we might be able to do a hypothesis test with the data. So basically, linear regression allows us to look at historical data and do some prediction about future outcomes, or forecasting. If you were in marketing, you would talk about doing forecasting. So we want to look at decisions made on the relationship between these two variables. In this particular assignment, we're just going to be looking at two variables. We will have an assignment we're going to be looking at multiple variables. So there's more than one type of regression analysis. Once data is collected, then we're going to look at this statistical analysis of regression to determine how these variables are related. And this variable then can be predicted by the dependent variable, which on the graph we'll see denoted by the letter Y. And the variable used to predict the value of the dependent variable is going to be the independent variable, and that's denoted by the letter X. So upon completion of this assignment, you should be able to analyze data through regression analysis to determine a relationship between two variables. So there's a spreadsheet that you can download, and I'll go to that here in a second. But in this spreadsheet, what we're looking at is the line speed and the number of defective parts that are found in an assembly line process. So in this manufacturing process, the assembly line speed was thought to affect the number of defective parts found during the inspection process. To test this theory, managers devised a situation in which the same batch of parts was inspected visually at a variety of line speeds as shown in this spreadsheet data. So when we're looking at what they're saying there's their theory, that's a hint because that's basically what our hypothesis is going to be. So we're looking at a hypothesis probably that says, the assembly line speed is thought to affect the number of defective parts during the inspection process, okay? So when you're looking at, when it says theory, that's generally a hypothesis. It's a clue to look for. That might be the hypothesis, okay? So I'm going to go through the directions here, and then I'm going to go into the spreadsheet and show you the step-by-step on how to do the assignment, okay? So we're going to develop a scatter plot with the line speed as the independent variable, that's the x-axis, and the defective parts as the dependent variable, that's the y-axis. Then we're going to explain what that scatter chart indicates about the relationship between the line speed. So is it going to be a positive slope? Is it going to be a negative slope? Or is there going to be no relationship at all? And we'll be able to see this once we do the scatter plot. We want to use the data to develop an estimated regression equation that could be used to predict the number of defective parts found given the line speed and state the intercept in the line speed. And we're going to use Excel to perform that. We're going to test whether each of the regression parameters is equal to 0 at 0.01 level significance. That's a 99% confidence level in Excel. And we're going to note that if the p-value represented by this significant f value in Excel is greater than 0.01 level significance. If it is, then you do not reject the null hypothesis. With this information, then once you have it, then you're going to need to answer the question, would you accept or reject the null hypothesis? And we gave you a hint earlier what that hypothesis might be. We're going to also look at how much variation in the number of defective parts are found for the same data that we use in the model that we estimated in question 2. And this is done by the representation of r squared, and it's generally written as percent. And I'll show you how to do that in Excel, then I'll try to explain how we would write that out. And then the final question is, if you're a manager in charge of quality control, explain what this data reveals about the relationship between line speed and the number of defective parts. Okay, so if it goes faster, is there something happening? If it goes slower, is there something happening? Somewhere in there, our analysis is going to be able to answer that question. So this is the Excel file that we download, and it says the line speed then is going to be our X value. So what I like to do is I go ahead and just put that in the caption here in the label. Then over here, this is going to be our Y, and I'll show you here in a second why that's important. Okay. So the first part is they want to make a scatter chart. So you just basically highlight these two values, go up to Insert, go over to Scatter Charts, and click on that. And there we have the number of defective parts found. And you see the defective parts is our vertical axis, our line speed is our horizontal axis. So as we did before, when we did a trend line, we just right click on any one of the dots, we add a trend line, and it comes up with our menu on the right. And you can see here the different types, and by default it's going to be linear. What we want to do now is we want to display the equation on the chart, and then we're also going to display the R squared on the chart, because the R squared is what's going to tell us the variability. I'm going to go ahead and close the menu, and I'm going to move this down over where we can see it a little better on the chart. Okay, so there's our equation, there's our R squared. Now the next part then, it says it wanted to for us to do a regression analysis. So we're going to do that in the Data tab, Data Analysis Tool Pack. Mine came up with regression because I had just practiced it, but when yours comes up, it might have another name on there. If not, then you've got a little scroll bar here. You can scroll to find regression. Click OK. This already had the data in it from when I did it a few minutes ago. I'm going to go ahead and blank it out so I can show you. So this is now why you put Y and X on the title, on the labels. Okay. So our first input range is Y. Now you see why I did that. And the next one is X. Now, if it's not already checked, go ahead and check labels because it's telling it the first row is a label. Go ahead and check confidence level. If you're doing this for the first time, it might come up with 95%, so you need to change it to 99. Output range, I just went ahead and clicked and did an output range over here. So this is where it's going to put the results of the regression analysis. I click OK, and there's the regression analysis. Okay. Now let me expand the columns a little so we can see that. We see our significant F. So that's our p-value. It's a 0.028. So from there, you should be able to determine whether to accept or reject the null hypothesis. You can see here also where our R squared is. We already had that in our, when we did the scatter plot right here. And then we had the line intercept. So here's line speed is X. Again, another reason to have that in the label. And then our intercept is here. So if we were wanting to predict how many defects we might have at 70 out here, because you see it stopped about 60, then we would put 70 in our equation there. So it'd be 0.1478 times 70 plus 22.174, and then that would tell us approximately how many defects that we might have. And if you'll notice, that's a negative sign. So that's a hint. And you look at the slope there, you can also determine whether that's a positive slope, a negative slope, or there's no relationship. So basically, the R square indicates the regression model explains a percent of the variability in line speed for the defects found. And so what we do is we would say, and you can see you can say 74%, but you can say this model explains whatever R square is, percent of the variability in the line speed for defective parts. Okay, so if we're looking at a significant level of significance of 0.01, we see that our significant F here is 0.02. So from that, you can decide whether to accept or reject. And then the final question was, what is your interpretation about line speed? Is it going to increase effective or decrease effective or have no effect at all? Okay. I hope this helps you with the homework assignment, and good luck.